Some of you have turned this test in and some of you haven't. I'm going to send a new one for those people that would like to do it again, or if you haven't done it, you'll do the new one, and this will be a little bit more review. So question number one, we have sodium carbonate and phosphoric acid. So we're going to balance the chemical equation first. And looks like we have 3 sodium atoms here and 2 here, so I'm going to have to put a 3 here and a 2 there. That makes 2 of these phosphates, so I put a 2 here, and that gives us 6 H's, so I put a 3 here. When I put the 3 there, that gave me 3 carbons, so I need to put a 3 over here too. So there's your balanced chemical equation. All right, first step in any stoichiometry problem is to change to moles, unless you already have moles. But in this case, you don't have moles. What you do have, you have 120 grams of that. So that has to be changed to moles. And you're looking for the gas. So which one of these 3 things over here would be produced as a gas? Well, hopefully we all recognize that carbon dioxide is a common gas. Water, of course, is a liquid. And sodium phosphate is a metal and a non-metal kind of compound, so it's going to be an ionic compound. In this case, it is a soluble ionic compound, so it'll actually be in solution. But the carbon dioxide is the gas, and we're looking for how many liters of that. All right, so the first thing you would want to do is change to moles. Okay, maybe I should write that down. Should I remind you? Change to moles. Then you do the mole ratio. And then you change to whatever unit you want. All right, so 120 grams of sodium carbonate. We'll change that to moles. 120 grams of sodium carbonate. You need to put grams down here. You need to put moles up here. 1 goes in moles, except in the mole ratio. And then if you add up the weight of the sodium and the carbon and the oxygen, maybe I'll remind you real quickly how to do that. So you go here. Sodium is 23, carbon is 12, oxygen is 16. 16 times 3 is 48. So if you add those all together, you get 106. And that's sodium carbonate and sodium carbonate. So that was the first step, change to moles. Second step, mole ratio, right here, mole ratio. So the mole ratio would be between what you're looking for and what you have. So in this case, we're looking for carbon dioxide. So we're going to say times, and we're going to put moles of sodium carbonate on the bottom because it needs to cancel. And moles of CO2 on top. And that's a 3-to-3 ratio. All right, final step in this problem would be to find the volume of gas. But in this problem, it's a little bit more complicated than just using the 22.4. All right, so you kind of have 2 options right here. You could go ahead and do the 22.4 moles per liter, or liters per mole conversion. So if we did that, I'll do that up here. We would have moles of CO2 on the bottom, and liters of CO2 on top, and 1 mole is 22.4 liters. And I'm not going to do it this way, but if I did do it that way, I would have the volume at STP. So that 22.4 is only true when the temperature is 0 degrees C and the pressure is 1 atmosphere, standard conditions. This problem is not at standard conditions because we have 780, not 760, and the temperature is 25 and not 0. So if you did this, that would give you the volume at standard, and then you would need to do a V1, V2, P1, P2, T1, T2 problem to solve for the volume at lab conditions, which are these conditions up here. So you'd have to do 1 more conversion. What this problem does, stoichiometry and gas law problems tie together the gas laws with stoichiometry. All right, alternatively to doing the 22.4, you could, and this is what I would suggest that you do, find the number of moles of CO2. So let's go ahead and do that. We have 120 grams of sodium carbonate. We're going to divide by 106, and so we have 1.13 moles of sodium carbonate right there. It's a 3-to-3 ratio, so it's just 1.13 moles of CO2. Okay, now could we find, if we know moles of CO2, can we find volume another way besides using a 22.4? Yes, you can. And that way is the ideal gas law. So PV equals nRT. Now it becomes a real simple plug and chug, just like the ideal gas law problems were kind of not super hard. So you got N equals 1.13 moles. R, I'm going to use 62.4. And I'm going to leave units off because of room here. And the temperature is 298. The pressure is 780, and we don't know volume. Okay, so I'm going to multiply these three numbers together. Are you understanding that we know the moles? This is R, the constant. This is the temperature in Kelvin. This is the pressure, 780. And we're going to be solving for volume. So to do that, I'm going to have 1.13 times 62.4 times 298. Then I'm going to divide by 780. Let me write this number down. This 1.13 times 62.4 times 298 is 21,013. We'll just call it, round it off a little bit, 21,013. And you have 780 on this side and volume. A common mistake that I've seen over the years is when you're trying to isolate the volume, you need to divide by the number that's with the volume. All too often I see people divide by this number. You do not. You divide by the number that's with the volume. So I have to divide both sides by 780. So I'm going to divide this by 780. They're going to cancel over here. So 21,013 divided by 780, 26.9 liters. And that was the final answer for the first problem. So 3 steps: change to moles, do the mole ratio, then change to your desired unit. Second problem. What mass of HCl will need to react with zinc? You have 25 milliliters of hydrogen gas collected over water. And it does mention that we need to look up the water vapor pressure from the link on the coronavirus homework page, so we'll do that. All right, balance this equation. Pretty simple balance on this one. You need to put a 2 there. All right, so what are the 3 steps? Again, you have to change to moles. But this time we have 25 milliliters, which is 0.025 liters. So I'm going to go ahead and our volume is equal to 0.025 liters. So one way you could change to moles is to take the 0.025 liters, and you'd need to change that to standard conditions. So the reason you need to change the standard conditions is because right here you cannot use the 22.4. This temperature is not standard temperature, and this pressure is not standard pressure, so you would have to use you couldn't use 22.4 until you change the 25 to standard conditions. And I'll show you that. And then that's not the way I would recommend doing it, but I'll show it to you nevertheless. Okay, so if you're going to go from 25 to 0, temperature is going down, so the volume would go down. So it would have 273 over 298 after you change to Kelvin. Okay, and then the pressure is not really 780, so let's deal with the pressure. It says it's 780, but it also says it's collected over water. So we have to subtract the water vapor pressure, as I taught you earlier in the Dalton's Law of Partial Pressure video that I made. So let's go back to that video. We'll go here, and we'll go to the coronavirus homework page, hopefully. Here we go. I put all these videos in one place on the video page, and also I organized this material here for you if you wanted to redo any of the previous quizzes. Okay, here's the water vapor chart right here. Okay, in this problem, the temperature was 25 degrees C. So let's go back over here and remind you what that looks like. So here's your 25 degrees C. So you come back over here. At 25 degrees C, the water vapor pressure in millimeters of mercury is 23.8. Notice the unit there is millimeters of mercury, and 23.8. So our actual pressure in the problem will be 780 minus 23.8. Since it's collected over water, we need to subtract the water vapor pressure. And what that means, again, is that if you have a gas in a container, the total pressure is 780. In this case, it's hydrogen and water vapor that make up the pressure. Well, the 23.8 is how much of that pressure is due to water vapor. So if you subtract them, you get the hydrogen pressure. So 780 minus 23.8, 756.2. So now this number is not 780 anymore, it's 756.2. When you do the calculation, if you did 756.2 going to 760, pressure is going up, so pressure goes up, volume goes down, so it'd be 756.2 over 780. Okay, so let's go ahead and do that. So 0.025 times 273 times 756.2 and then divide by 298 and divide by 780. So I get 0.022 liters. Now you can change to moles. So you could do liters here, you could do moles here, and 1 mole is 22.4 liters. So divide this number by 22.4, and you get 0.000991 moles, or 0.00099 moles. All right, so that's one way to find the number of moles. Now remember, that was just the first step. Change to moles. So now we have that many moles of hydrogen. Okay. Now, the other way to change to moles, which I think is an easier way to do it, is use PV equals nRT. So let's do that. So PV equals nRT. P, I showed you how to calculate it. You have to do that water vapor thing in either case. So it's 756.2 for pressure. Volume, 0.025 liters. I'm going to call that torr. All right. Torr is the same as millimeters of mercury. Equals N, and now R. R has 3 values. I'll write them up here to remind you. R equals 0.0821 liter atmospheres over mole Kelvin equals 8.31 liter kilopascals per mole Kelvin equals 62.4 liter torr per mole Kelvin. So any one of those 3 units, or 3 numbers you can use for R depending upon the unit of pressure. You see everything's the same in all of them except for the pressure unit, atmospheres, kilopascals, torr. Since this problem is in torr, or millimeters of mercury, you should use the 62.4 value for R right here. Now remember, a torr and a millimeter of mercury, same thing. Okay, so I'm going to use the 62.4, and that's liter torr per mole Kelvin. And then the temperature is 298 K. 273 plus 25. You have to add them together. All right, so what's in? All right, am I going to divide by the stuff that's on the left, or am I going to divide by the stuff that's on the right? Well, since the variable is on the right and you need to get rid of the material that's with the variable, then you divide by these numbers. So I'm not going to show the products. I'm just going to go ahead and do the math and watch what I do on a calculator. So I've got 756.2 times 0.025 equals. Now I'm going to divide by 62.4 and divide by 298. Divided by 62.4 and divide by 298. Okay, so my N value is 0.00102. Now, this number moles, and this number should equal each other. And if I round them a little bit more, they will. See, if I took this number and rounded off to the nearest thousandths place, that's followed by a 9, so that becomes that's followed by a 9, so that would go up to a 0.001. So in other words, this 0 would round up to a 1 because it's followed by a 9. And see that 0.001? So these are essentially the same number. It's the difference in them is because of the way I rounded off in the middle of the problem, and I didn't watch my sig figs close enough. But since I don't want to restart the whole video and do it again, you're just going to have to accept that this number and this number are essentially the same. Once again, 0.00099 causes this 0 to round up to a 1, so that really is 0.001, which is the same as this one, 0.001, if you only go to 1 sig fig. Okay, now we'll take our N value, our number of moles. This is moles of hydrogen. So we have 0.001 moles of hydrogen. In this problem, we want to know the mass of HCl. So our question mark's over here. We had 25 milliliters of this, and we want to find that. So we're going to put moles of hydrogen on the bottom, and we're going to put moles of HCl on the top. This is the mole ratio step. What was step 1? Change to moles. Step 2, mole ratio. So we'd have 2 in front of the HCl, 1 in front of the hydrogen. And then our last step will be to change to our desired unit. Change to unit. So our desired unit here was mass. I'm going to put moles of HCl on the bottom, grams of HCl on the top. 1 mole is 36.5 grams. And once again, that comes from the periodic table. So 0.001 times 2 times 36.5. There's nothing on the bottom to divide by. So our final answer, 0.073 grams of HCl. All right, that's problem number 1 and number 2. I'm going to make a separate video for 3 and 4 because they get long, take a long time to upload.